Hi, good morning students. As you know already, in the last class or in the previous classes we already completed some theorems and related problems. So among those theorems we already completed basic proportionality theorem, or it may also call it as Thales theorem, and second one is converse of basic proportionality theorem, or it may also call it as converse of Thales theorem, and the third theorem is AAA criterion, or it may call it as AAA similarity criterion, or it can also be considered as angle similarity criterion. And we already know about some problems, or we solved some problems regarding to these three theorems in earlier classes. So today we are going to discussing about another very important theorem. So that theorem is areas of similar triangles. Before going to this particular theorem, I would like to give you some ideas about how to prove the proof of this particular theorem. So that is very important, and before going to the prove this theorem, we should know the statement of this theorem. First of all, you should observe the statement, or you should understand the given statement of this theorem properly. Then only you can easily understand the exact proof of this theorem, right? So now I would like to tell you the statement of this theorem. You just observe the statement. The ratio of the areas of two similar triangles is equal to the square of their corresponding sides, or square of the ratio of their corresponding sides. Square of the ratio of their corresponding sides. So this is the exact statement of this particular theorem. The theorem is areas of similar triangle. So this is 2.6th theorem. So today we are going to discussing about the exact proof of this theorem, right? So once again I would like to tell you the statement of this theorem. The ratio of the areas of two similar triangles. We already know about the definition of ratio, right? So what about ratio? Ratio is nothing but fractions. It has a numerator and denominator, right? So it can be represented in A by B form or P by Q form, right? So this is called A by B form. So it can also be written as A is to B. So this is called it as ratio. So ratio can also be written as A by B. That's why. So they are given here the ratio of the areas of two similar triangles. Then what is the areas of two similar triangles? So in this particular statement we have two triangles. So that is very important, and those two triangles are similar to each other. So here those two triangles are similar means the three pairs of corresponding angles are equal and three pairs of corresponding sides are proportional. So that is very important criteria for similar triangles. So then the areas of those two triangles, that means area of one triangle, you may consider that as a triangle ABC divided by area of triangle, one more triangle, that is DEF. You can consider triangle DEF. So this is ratio, right? So ratio is nothing but fraction. That's why we can taken the given statement, the ratio of the areas of two similar triangles like this. Area of triangle ABC divided by area of triangle DEF. We know that triangle ABC and triangle DEF, these two are similar to each other. So that is very important. So then we moving on the statement here, is equal to the. So is equal to the means you just put equal symbol here and then continue the statement. Is equal to the square of the ratio. Again we should take down another ratio. So that ratio should be the ratio of their corresponding sides. So square of the ratio of their corresponding sides, that means in triangle ABC and DEF, AB is corresponding to DE and BC is corresponding to EF and AC is corresponding to DF. That's why we should write down like this: BC square divided by EF square, or because we know that BC is corresponding to EF, that's why we should write down square of the ratio of their corresponding sides. That means if you consider BC from this triangle, then you should consider EF from triangle DEF, because these two are corresponding to each other. So then another pair is there. So that is AB square divided by DE square, or you may consider AC square divided by DF square. So this is the proof of this theorem. You just prove one of these statements. So that's it. ಅಂದ್ರೆ ಇಲ್ಲಿ ಓವರಾಲ್ ಸ್ಟೇಟ್ಮೆಂಟ್ ಬಗ್ಗೆ ನಾನು ಮೀನಿಂಗ್ ಹೇಳ್ತಾ ಇದ್ದೀನಿ ಇಲ್ಲಿ. ಸೊ ಅಂದರೆ ದ ರೇಷಿಯೋ ಆಫ್ ದ ಏರಿಯಾಸ್ ಆಫ್ ಟೂ ಸಿಮಿಲರ್ ಟ್ರಯಾಂಗಲ್ಸ್ ಅಂದರೆ ಯಾವುದೇ ಎರಡು ಟ್ರಯಾಂಗಲ್ಗಳು ಸಿಮಿಲರ್ ಆಗಿದ್ರೆ, ಸೊ ಆ ಎರಡು ಸಿಮಿಲರ್ ಟ್ರಯಾಂಗಲ್ಸ್ನ ಏರಿಯಾ ಫೈಂಡ್ ಔಟ್ ಮಾಡೋದು ಯಾವ ರೀತಿ ಅಂತ ಗೊತ್ತಿದೆ. ಹಾಫ್ ಇಂಟು ಬೇಸ್ ಇಂಟು ಹೈಟ್ ಅಂತ ಫಾರ್ಮುಲಾ ಯೂಸ್ ಮಾಡ್ತಿರಲ್ಲ, ಆ ಎರಡು ಏರಿಯಾಸ್ ಟೂ ಟ್ರಯಾಂಗಲ್ಸ್ನ ಏರಿಯಾನ ರೇಷಿಯೋದಲ್ಲಿ ಬರೆದ್ರೆ ಆ ರೇಷಿಯೋ ಯಾವುದಕ್ಕೆ ಈಕ್ವಲ್ ಆಗಿರುತ್ತೆ ಅಂದರೆ ಅವುಗಳ ಕರೆಸ್ಪಾಂಡಿಂಗ್ ಸೈಡ್ಸ್. We know that 3 pairs of corresponding sides are there in two similar triangles. ಸೊ ಅಂದರೆ ಮೂರು ಜೊತೆ ಕರೆಸ್ಪಾಂಡಿಂಗ್ ಸೈಡ್ಸ್ಗಳಿರ್ತವೆ. ಆ ಮೂರು ಜೊತೆಲಿ ನೀವು ಯಾವುದಾದ್ರೂ ಒಂದು ಪೇರ್ನ ತೊಗೊಂಡು ಅದಕ್ಕೆ ಸ್ಕ್ವೇರ್ ಅಪ್ಲೈ ಮಾಡಿದ್ರೆ, ಸೊ ದಟ್ ಈಸ್ ಕಾಲ್ ಇಟ್ ಆಸ್ ಏರಿಯಾಸ್ ಆಫ್ ಸಿಮಿಲರ್ ಟ್ರಯಾಂಗಲ್. ಸೊ ಅದಕ್ಕೆ ನಾವು ಏರಿಯಾಸ್ ಆಫ್ ಸಿಮಿಲರ್ ಟ್ರಯಾಂಗಲ್ ಅಂತ ಕರಿತೀವಿ. ಸೊ ಹಾಗಾದರೆ ಈ ಥಿಯರಮಲ್ಲಿ ನಾವೇನನ್ನು ಪ್ರೂವ್ ಮಾಡಕ್ಕೆ ಹೊರಟಿದ್ದೀವಿ? ಏರಿಯಾ ಆಫ್ ಟ್ರಯಾಂಗಲ್ ABC ಡಿವೈಡ್ ಬೈ ಏರಿಯಾ ಆಫ್ ಟ್ರಯಾಂಗಲ್ DEF ಈಸ್ ಈಕ್ವಲ್ ಟು square of their corresponding sides. So we just considered here BC square divided by EF square. So that is we are going to prove in this theorem. So now we moving on the proof section of this theorem. You just observe here. First of all, we know about data first. So data, or it may also call it as given information. So in data section we know that triangle ABC similar to triangle DEF, because in the statement they are given those two triangles are similar to each other. You just draw two triangles here, ABC, and you just consider one more triangle, that is DEF, right? These two triangles are similar. Then we know that these pair of angles are equal, because in two similar triangles 3 pairs of corresponding angles are equal. That's why we mark like this, right? So in these two triangles, similar triangles, we know that their corresponding sides are also proportional. That's why we should taken like this: AB by DE is equal to BC by EF also equal to AC by DF. So this is the given information from this statement, right? So now we moving on to prove. What we are going to prove here, I already told you the proof of this theorem. So that proof is area of, here the taken triangles are triangle ABC divided by area of triangle DEF. This is equal to the square of their corresponding sides. So those corresponding sides are, you may consider BC square divided by EF square, or you may take down like AB square divided by DE square or AC square divided by DF square. ನೀವು ಯಾವುದಾದ್ರೂ ತಗೋಬಹುದು. ಸೊ ನಾನಿಲ್ಲಿ BC ಸ್ಕ್ವೇರ್ ಮತ್ತು EF ಸ್ಕ್ವೇರ್ನ ಯಾವ ರೀತಿ ಪ್ರೂವ್ ಮಾಡೋದಂತ ಹೇಳ್ಕೊಡ್ತೀನಿ. ಸೊ ನೀವು ಯಾವ್ದು ಬೇಕಾದರೂ ಪ್ರೂವ್ ಮಾಡ್ಬೋದು, ಅವ್ರು ಪರ್ಟಿಕ್ಯುಲರ್ ಆಗಿ ಇದೇ ಪ್ರೂವ್ ಮಾಡಿ ಅಂತ ಕೇಳಲ್ಲ. ಸೊ you just keep it in your mind. So now then the construction, we moving on construction. Each and every theorems, those are having some construction here. So that construction is, we know that this particular theorem is related to areas of two similar triangles, right? So you just observe that word area. So what is the area of triangle? Yes, of course, we know that area of triangle is equal to the half into base into height. We should know about the area of these two similar triangles. How can you find the area of triangle? By using the only formula, that is half into base into height. Yes, of course, we know that several formulas are there for finding the area of triangles. Andre triangle na area find out madlikke tumba formulas galidave, like Heron's formula, or like equiangular or equilateral triangles another formula is there. So but here we should focus on the basic formula, that is area of triangle is equal to half into base into height. So in these two triangles we can easily identify the base of these two triangles. What is the base of first triangle? BC is the base. And what is the base of second triangle? That is EF. So now here the construction is, you just draw two perpendiculars on the base of these two triangles. So you just draw AL is perpendicular on BC. So here AL is called it as altitude or height of the triangle ABC. Altitude or height, both are same. So then here DM is perpendicular on EF. That means DM is the altitude or height of the second triangle. The triangle is DEF, right? By using these two formulas, I would like to give you some idea before going to the proof section, right? You just write down the construction first. Draw AL perpendicular on BC, and what about next? DM is perpendicular on EF. So you just observe the proof of this theorem. This is very easy. So if you understand the given statement and data or given information and the given figures, so then you can easily understand the entire proof of this theorem, right? So before going to the proof of this theorem, I would like to give you some idea about how to remember or how to think about the oral proof for finding the step by step. You just observe here. For example, we have to prove area of triangle ABC divided by area of triangle DEF, right? This is equal to, what about the area of triangle ABC? Half into base. Here base is BC into height. What is the height of this triangle? AL, right? So then what about here? Half into, what is the base of the triangle? EF into the height is DM. So we know that half get cancelled out. So then what will remain? So here BC by EF into AL by DM. This is very important. Finally, we got this value. BC by EF into AL by DM. What about the required proof here? BC square divided by EF square. So now we got an idea about, some idea about the proof. So if you interchange AL by DM as BC by EF, then you can easily get the final proof of this theorem. So that is the very important point. How can you convert the ratio AL by DM as BC by EF? So that is very important point in this theorem. So ಅದಕ್ಕೆ ನಾವು ಟರ್ನಿಂಗ್ ಪಾಯಿಂಟ್ ಅಂತ ಕರೆಯೋದು. ಇಲ್ಲಿವರೆಗೂ ಮಾಡ್ಬಿಡ್ತೀರಾ, ಡೈರೆಕ್ಟ್ ಆಗಿ ಗೊತ್ತಾಗ್ಬಿಡುತ್ತೆ. ಏರಿಯಾ ಆಫ್ ಟ್ರಯಾಂಗಲ್ ABC ಅಂದ್ರೆ ನಮಗೆ ಬೇಸಿಕಲಿ ಗೊತ್ತು, ಫಾರ್ಮುಲಾ ಹಾಕ್ತೀವಿ. ಏರಿಯಾ ಆಫ್ ಟ್ರಯಾಂಗಲ್ DF ಅಂದ್ರೂ ಕೂಡ ಗೊತ್ತು, ಹಾಕ್ತೀವಿ. BCEF ಸಿಗುತ್ತೆ. ಬಟ್ ಆದ್ರೆ BC ಸ್ಕ್ವೇರ್ ಆಗ್ಬೇಕಂದ್ರೆ AL ಜಾಗದಲ್ಲಿ BC ಬೇಕು, EF ಸ್ಕ್ವೇರ್ ಆಗಬೇಕು ಡಿನಾಮಿನೇಟರ್ ಅಲ್ಲಿ ಅಂದ್ರೆ DM ಜಾಗದಲ್ಲಿ EF ಬರಬೇಕು. ಸೊ ನಾವಿಲ್ಲಿ AL by DM ಅನ್ನೋ ರೇಷಿಯೋನ BC by EF ಅಂತ ಕನ್ವರ್ಟ್ ಮಾಡಬೇಕು. ಯಾವ ರೀತಿ ಕನ್ವರ್ಟ್ ಮಾಡ್ತೀರಾ? ಸೊ ದಟ್ ಈಸ್ ವೆರಿ ಇಂಪಾರ್ಟೆಂಟ್. ಇಫ್ ಯು ಕನ್ಸಿಡರ್ ದೀಸ್ ಎನಿ ಟೂ ಟ್ರಯಾಂಗಲ್ಸ್ ಲೈಕ್ ALB and DME, ಜಸ್ಟ್ ಅಬ್ಸರ್ವ್ ಮಾಡಿ. ಸೊ ALB ಟ್ರಯಾಂಗಲ್ ಮತ್ತು DME ಟ್ರಯಾಂಗಲ್ನ ತಗೊಂಡು ನೀವು ಅವೆರಡು ಟ್ರಯಾಂಗಲ್ ಏನಂತ ಪ್ರೂವ್ ಮಾಡಬೇಕು, ಸಿಮಿಲರ್ ಅಂತ ಪ್ರೂವ್ ಮಾಡಬೇಕು. ಸೊ ದಟ್ ಈಸ್ ವೆರಿ ಈಸಿ ಮೆಥಡ್ ಟು ಪ್ರೂವ್ ದೀಸ್ ಟು ಟ್ರಯಾಂಗಲ್ಸ್ ಆರ್ ಸಿಮಿಲರ್ ಬೈ ಯೂಸಿಂಗ್ AA ಸಿಮಿಲಾರಿಟಿ ಕ್ರೈಟೀರಿಯನ್. ಹೌದಲ್ವಾ? AA ಸಿಮಿಲಾರಿಟಿ ಕ್ರೈಟೀರಿಯನ್ ಯೂಸ್ ಮಾಡಿ ಈಸಿಯಾಗಿ ಪ್ರೂವ್ ಮಾಡ್ಬೋದು. ಬಿಕಾಸ್ ವಿ ನೋ ದಟ್ ಆಂಗಲ್ B is equal to angle E. We already know about these two are similar. So then here angle L is equal to angle M because these two are right angles. That's why according to those two angles, according to AA similarity criterion, we know that ALB is similar to DME. ಸೊ ನೀವು ಕೇಳ್ಬೋದು, ಸರ್ ಇವೆರಡು ಸಿಮಿಲರ್ ಅಂತ ಪ್ರೂವ್ ಮಾಡಿದ ತಕ್ಷಣ ಏನು ಗೊತ್ತಾಗ್ಬಿಡುತ್ತೆ ನಿಮಗೆ? ಎಸ್, ಅಫ್ಕೋರ್ಸ್, ದಟ್ ಈಸ್ ಆಲ್ಸೋ ವೆರಿ ಇಂಪಾರ್ಟೆಂಟ್ ಪಾಯಿಂಟ್. ಸೊ ಇಫ್ ಯು ಕನ್ಸಿಡರ್ ದೋಸ್ ಟು ಸಿಮಿಲರ್ ಟ್ರಯಾಂಗಲ್ಸ್, ದೆನ್ we get AB by DE is equal to AL by DM, right? This is also a corresponding pair of ratios. So you just observe here, AL by DM is equal to AB by DE. So in the given data section, AB by DE is also equal to BC by EF, and BC by EF is also equal to AC by DF. So these three pairs of corresponding sides are proportional. That's why we can taken AL by DM as BC by EF. So finally, this is the exact proof of this theorem. So this is the postmortem of this theorem, that is 2.6 theorem. So then you just write down that theorem step by step. That is the remaining proof of this theorem. I hope you all understand the proof of this particular theorem. So now we moving on the writing work of this theorem. ಸೊ ಅಂದರೆ ನಾವೀಗ ಕಂಪ್ಲೀಟಾಗಿ ಥಿಯರಮ್ನ ಅನಲೈಸ್ ಮಾಡಾಗಿದೆ. ಸೊ ಈಗ ಜಸ್ಟ್ ರೈಟಿಂಗ್ ವರ್ಕ್ ಮಾತ್ರ ಬಾಕಿ ಇರೋದು. ಯಾವ ರೀತಿ ಬರಿತಾ ಹೋಗ್ತೀವಿ ಸ್ಟೆಪ್ ಬೈ ಸ್ಟೆಪ್ ಅಂತೇಳಿ ಒಂದು ತಲೆಯಲ್ಲಿ ಇಟ್ಕೊಂಡಿರಿ. ಫಸ್ಟ್ ನೀವು ALB ಆರ್ DME ಟ್ರಯಾಂಗಲ್ನ ಸಿಮಿಲರ್ ಅಂತ ಪ್ರೂವ್ ಮಾಡಿ ರೇಷಿಯೋಗಳನ್ನ ಬರ್ಕೊಂಡ್ಬಿಡ್ಬೇಕು. AB by DE is equal to AL by DM ಅಂತೇಳಿ. ನೆಕ್ಸ್ಟ್ ಏನು ಮಾಡಬೇಕು, ನಾನು ಇಲ್ಲಿ ಬರ್ದ್ನಲ್ವಾ, ಏರಿಯಾ ಆಫ್ ಟ್ರಯಾಂಗಲ್ ABC ಡಿವೈಡ್ ಬೈ ಏರಿಯಾ ಆಫ್ ಟ್ರಯಾಂಗಲ್ DEF ಅಂತ ಬರೆದು ಫಾರ್ಮುಲಾ ಅಪ್ಲೈ ಮಾಡಬೇಕು, ಟ್ರಯಾಂಗಲ್ ಫಾರ್ಮುಲಾನ. ಆ ಫಾರ್ಮುಲಾದಲ್ಲಿ BC by EF ಸಿಗುತ್ತೆ, AL by DM ಇರುತ್ತೆ. ಆ AL by DM ನ ಪ್ರೀವಿಯಸ್ ಕರೆಸ್ಪಾಂಡಿಂಗ್ ರೇಷಿಯೋ ಜೊತೆ ಕಂಪೇರ್ ಮಾಡಿ ನೀವೇನಂತ ಬರ್ಕೋಬೇಕು, AL by DM ನ BC by EF ಅಂತಲೂ ಕೂಡ ಬರಿಬೋದು ಅಂತ ತೋರಿಸ್ಬೇಕು. ಆಗ ನಿಮಗೆ ಪ್ರೂಫು ಸಿಕ್ಕಾಗುತ್ತೆ. ಸೊ ದಟ್ ಈಸ್ ಅ ವೆರಿ ಇಂಪಾರ್ಟೆಂಟ್ ಆ್ಯಂಡ್ ವೆರಿ ಈಸಿ ಥಿಯರಮ್. ಸೊ ನಾವು ವಿ ಮೂವಿಂಗ್ ಆನ್ ದ ಪ್ರೂಫ್ ಆಫ್ ದಿಸ್ ಥಿಯರಮ್. ಸೊ here the required proof is, you just consider two triangle, ಕನ್ಸಿಡರ್ ಏನಕ್ಕೆ ಅವನು ಕನ್ಸಿಡರ್ ಮಾಡ್ಬೇಕಂತನೂ ಕೂಡ ನನ್ನ ಐಡಿಯಾ ಕೊಟ್ಟಿದ್ದೀನಿ. ಸೊ ರೈಟ್ ಆ್ಯಂಗಲ್ ಟ್ರಯಾಂಗಲ್ ALB ಆ್ಯಂಡ್ ರೈಟ್ ಆ್ಯಂಗಲ್ ಟ್ರಯಾಂಗಲ್, what about next, DME. So in these two triangles, we know that angle B is equal to angle E. These two are corresponding sides are in the given data, right? These two are similar triangles, then angle B is equal to angle E. So then one more angle is there, that is angle ALB is equal to angle DME. Both are equal to right angles because we know that AL is perpendicular on BC from construction, right? You may write down here from construction. So according to AA similarity criterion, therefore right angle triangle ALB is similar to right angle triangle DME according to AA similarity criterion. Therefore from these two similar triangles, you just take down one ratio, that is AB by DE is equal to, ನಮಗೆ ಬೇಕಾಗಿರೋದು ಮಾತ್ರ ತಗೋಬೇಕು, AL by DM. So consider this as equation number 1, right? So now we moving on the second one, that is in triangle ABC similar to triangle DEF, you just apply the area formula among these two triangles, then we get area of triangle ABC divided by area of triangle DEF is equal to, what about the area of triangle ABC? Half into, here base is BC into height is AL because AL is the altitude, divided by, here also you just write down the formula, half into, so what about the base of second triangle? EF into height is DM. because here area is equal to half into base into height. So this is very important formula. So now here 1 by 2 get cancelled out. So this is equal to BC by EF into AL by DM. So from the given data or from equation number 1, AB by DE is equal to AL by DM. So from given data, AB by DE is also equal to BC by EF. So you just write down here from equation number 1, we get area of triangle ABC divided by area of triangle DEF is equal to BC divided by EF into, here you just write down AL by DM in place of AL by DM as AB by DE, right? AB by DE. From given data or from data, so from data section we have area of triangle ABC divided by area of triangle DEF is equal to BC by EF into BC by EF. So in the given section, you just observe here AB by DE is also equal to BC by EF. That's why we can easily take down BC by EF in place of AB by DE. That is very important. So this is equal to, or this implies BC into BC square divided by EF into EF square. So now you get the exact proof of this theorem, that is area of triangle ABC divided by area of triangle DEF is equal to the square of their corresponding sides, that is BC square divided by EF square. So the final proof is here area of triangle ABC divided by area of triangle DEF is equal to BC square divided by EF square, or you may write down this like this, right? BC square divided by EF square, it can be represented like BC by EF whole square. So this is the proof of this theorem. So by using this particular condition, we can solve so many problems regarding to this theorem. So ಈ ಥಿಯರಮ್ ಅಲ್ಲಿ ಯಾವುದೇ ತರಹದ ಕನ್ಫ್ಯೂಷನ್ಸ್ ಇರಲ್ಲ. ಸ್ಟೇಟ್ಮೆಂಟ್ ಅಲ್ಲಿ ಏರಿಯಾ ಆರ್ ಥಿಯರಮ್ ನಲ್ಲಿ ನೇಮ್ ಅಲ್ಲಿ ಏರಿಯಾ ಅಂತ ಇತ್ತು ಅಂದ್ರೆ ಅದು ಏರಿಯಾಸ್ ಆಫ್ ಸಿಮಿಲರ್ ಟ್ರಯಾಂಗಲ್ ಅಲ್ಲೇ ಇರುತ್ತೆ. ಬಿಕಾಸ್ ಪೈಥಾಗರಸ್ ಅಲ್ಲಿ ಏರಿಯಾ ಅಂತ ಬರಲ್ಲ, BPT ಲಿ ಏರಿಯಾ ಅಂತ ಬರಲ್ಲ, ಮತ್ತೆ AA ಸಿಮಿಲಾರಿಟಿ ಕ್ರೈಟೀರಿಯನ್ ಕೂಡ ಏರಿಯಾ ಅಂತ ಯಾವುದೇ ಬರಲ್ಲ. ಏರಿಯಾ ಅನ್ನೋ ವರ್ಡ್ ಬರೋದಿದ್ರೆ ಅದು ಏರಿಯಾಸ್ ಆಫ್ ಸಿಮಿಲರ್ ಟ್ರಯಾಂಗಲ್ಸ್ದೇ ಆಗಿರುತ್ತೆ. ಕನ್ಫ್ಯೂಸ್ ಮಾಡ್ಕೋಬೇಡಿ, ಯಾವುದೋ ಥಿಯರಮ್ನ ಯಾವುದಕ್ಕೋ ಬರೆಯೋದು. ಸೊ ಇದರಲ್ಲಿ ಜಸ್ಟ್ ಥಿಂಕ್ ಮಾಡಬೇಕು ಅಥವಾ ಐಡೆಂಟಿಫೈ ಮಾಡಬೇಕಾಗಿರೋಂಥ ಒಂದೇ ಒಂದು ಪಾಯಿಂಟ್ ಅಂದರೆ ಅದು ALB ಟ್ರಯಾಂಗಲ್ ಆ್ಯಂಡ್ DME ಟ್ರಯಾಂಗಲ್ನ ಸಿಮಿಲರ್ ಅಂತ ಪ್ರೂವ್ ಮಾಡೋದು ಒಂದೇನೇ ಇಂಪಾರ್ಟೆಂಟು. ಸೊ ಅದು ಸಿಮಿಲರ್ ಅಂತ ಯಾಕೆ ಪ್ರೂವ್ ಮಾಡಬೇಕು ಅನ್ನೋದು ನಿಮಗೆ ಐಡಿಯಾ ಬಂದರೆ ಸೊ ನಿಮಗೆ ಎಂಟೈರ್ ಪ್ರೂಫು ಯಾವುದೇ ಕಾರಣಕ್ಕೂ ಮರ್ತೋಗಲ್ಲ. ಸೊ this is the proof of this theorem. So once again I'd like to tell you the statement here. The ratio of the areas of two similar triangles, you should consider similar triangles, not any other triangles. So if you write down those areas in the given ratio, so then that ratio is equal to the square of their corresponding sides. ಅವುಗಳ ಕರೆಸ್ಪಾಂಡಿಂಗ್ ಸೈಡ್ಸಿನ ಸ್ಕ್ವೇರ್ಗೆ ಆ ಏರಿಯಾಸಿನ ರೇಷಿಯೋಸ್ ಏನಾಗಿರುತ್ತೆ, ಈಕ್ವಲ್ ಆಗಿರುತ್ತೆ. ಸೊ ದಿಸ್ ಈಸ್ ದ ಪ್ರೂಫ್ ಆಫ್ ದಿಸ್ ಥಿಯರಮ್. ಐ ಹೋಪ್ ಯು ಆಲ್ ಅಂಡರ್ಸ್ಟ್ಯಾಂಡ್ ದ ಪ್ರೂಫ್ ಆರ್ ಸಿಂಪಲ್ ಪ್ರೂಫ್ or very easiest proof of this 2.6th theorem. So that theorem is areas of similar triangle. So I hope you all understand today's class. We will meet you in the next class. Thank you.